Hello class and welcome to another video lesson. This is the topic of melting, boiling and evaporation. And in this topic, we're going to talk about what happens to the molecules, what happens to the energies when the substance is undergoing a change in state. So from solid to liquid, liquid to gas, and also the reverse. Okay, so we're going to talk about what happens during melting, during boiling, and during evaporation. So this is part one of this particular topic. And in this first part, we're going to talk about melting specifically. Before we can talk about melting, let's just generally talk about what happens to the temperature of a substance when a substance is undergoing a change in state. Or in other words, when they are going from solid to liquid or liquid to gas or vice versa. So what happens to the heat energy and temperature when a substance is changing state? Let's take, for example, ice at minus 10 degrees Celsius. So this is ice. This is the solid state of water. And we will have a graph to show the temperature against time for this ice. So the ice started at minus 10 degrees Celsius. This y-axis will tell you its temperature, and this x-axis will tell you a time. So as you heat it up, so we heat up this ice, what happens to it? Its molecules gain internal energy and its temperature increases from minus 10 degrees Celsius to minus 1 degree Celsius. So let's look at the graph. So as you can see, when you heat up the ice increases its temperature. Nothing unusual there. But when it reaches 0 degrees Celsius, the ice will start to melt. However, the temperature stops rising during this process, but only for a while. So let's draw that on the graph. So at 0 degrees Celsius, the temperature of the ice remains constant. So it's almost a straight line there. So the temperature stays at 0 degrees Celsius until the ice has completely melted. Once the ice has completely turned into water, so it's melt, the temperature will start to rise again. So you can see, so this is the start of the melting process, and this is the end of the melting process. Once everything has fully melted, then the temperature starts to rise again as normally. So in fact, whenever a substance is undergoing a change in state, its temperature stays constant. So this is very important. Okay, even though we are still giving heat energy to this substance, to this ice, the temperature remains constant whenever there is a change of state. So in this case, when it's melting, its temperature remains at 0 degrees Celsius, even though we are still heating it up. So the question is, why during this process we still give it energy, we still heat up the ice, but the temperature remains the same? So this will be answered in part 5 or 6 in this topic. But for now, we're just going to talk about melting in more detail. So melting is defined as the process whereby the energy transfer, so the heat energy that we use, changes the state of a substance from solid to liquid. And very important, this happens at a constant temperature. Okay, so melting always happens for a certain period of time, and during this period, the temperature doesn't change, it's constant. So for pure substances, melting occurs at a constant temperature called the melting point. So each substance have different melting points, and we are very familiar with water or ice. Ice has a melting point of 0 degrees Celsius. Gold, on the other hand, has a very high melting point. So in other words, you need very high temperatures to melt gold. Alcohol, you don't need a high melting point to melt alcohol. This means that gold, for instance, will change into liquid gold when it is at a temperature of 1067 degrees Celsius. So if we observe the temperature of melting substances, let's take, for example, ice, we will see a pattern shown below. So if you plot a graph of temperature against time for any melting substance, it will always show this type of graph. It will always show this curve, any melting substance, whether it's a metal, gold, or alcohol, it will always show this graph. Okay, and this graph in particular, we are trying to show ice. So let's break down this graph one by one and what's happening with this graph. So this graph is known as a heating curve. So it's a curve that it curves upwards and the temperature is increasing. So it's a heating curve. It shows that the original temperature of the ice was minus 10 degrees Celsius. So this is the starting temperature of ice. And then as we heat it up, you can see the temperature rises. And then when it reaches 0 degrees Celsius, so at point Q, the temperature begins to stay constant. In fact, at position Q and R, so at this straight line here, it is changing state and the process is called melting. The ice is melting. So whenever you see a straight horizontal line in a heating curve, that could mean that at that point the substance is melting. So you will see that at the start, Q, this is the start of the melting process. At Q, everything is ice, so everything is solid. Okay, so you can see at this point here, everything is still solid, everything is ice. But then once Q has started, now you have a mixture of ice and water because that ice begins to melt. So you have ice and water between Q and R. But once we reach R, so this is the end of the melting process, then you only have water. Okay, so from P to Q, it's only solid. Q to R, you have a mixture of solid and liquid. And then R to S, R onwards, you only have liquid. Once all the ice has melted, position R, temperature continues to rise and the ice is now liquid water. The constant temperature at which a substance melts is known as the melting point. So it's this point here. So that straight horizontal line is the melting point of this substance. And for this particular graph, the melting point is 0 degrees Celsius. And that is it for part 1 for the time being. So in part 1, we talk about what is melting. So remember, the definition of melting is this one here. Melting is a process where energy transfer changes the state of a substance from solid to liquid. And also very important, melting only occurs at a constant temperature. Make sure you remember that ice has a melting point of 0 degrees Celsius. And then make sure you know that this curve is called the heating curve. And make sure you are able to identify which temperature is the melting point just by looking at this heating curve. So if you want to know where is the melting point or where the substance melts, it is when the graph is a horizontal straight line. So horizontal straight line, you look at the temperature and you can tell that for this substance, this is in fact water, it has a melting point of 0 degrees Celsius. For part 2, we're going to talk about solidification, also known as freezing.